Hello friends, welcome back to this new video. So from this video we will be looking at the exercise 6.3 which is there in your new syllabus. So in the previous videos which we have seen, there I have covered the questions from our old textbook. Okay, so let's start the exercise 6.3. So the first question is, find the vector equation of the plane. Let me copy this. Okay, find the vector equation of the plane which is at a 42 unit distance from the origin and which is a normal to the vector 2i plus j minus 2k. Okay, so we will follow our same strategy. So what is our strategies? Write down step number 1, which is nothing but the given information. So what they have given is, they have given the plane is lying at a 42 units distance from the origin, and we have seen that this distance is denoted by p. Okay, so p is equals to 42 units, and the normal vector we denote it by n bar, which is nothing but 2i plus j minus 2k. Okay, so after reading this question we can simply understood that this is the normal form of the equation they are asking. Okay, so the normal form of the equation of the plane is given as normal form of a plane is given as r bar dot n cap, it is equals to p. Okay, so but we don't know the value what is n cap is. N cap is simply the unit vector of this n bar. So let's find out the n cap. So n cap is nothing but vector divided by its magnitude. So it's a 2i plus j minus 2k whole divided by root of 2 square is 4 plus 1 square is 1 plus 2 square is 4. Okay, so this is equals to 2i plus j minus 2k divided by, it's a root of 9, so that becomes 3. Okay, once you have the n cap and already there they have given that p, so let's substitute this in the form r bar dot n cap is equals to p. So that is nothing but r bar dot n cap is what? It's a 2i plus j minus 2k whole divided by 3. Okay, let me have whole divided by 3, it is equals to p is they have given as a 42. Okay, just multiply by 3 on both sides, so we will get r bar dot 2i plus j minus 2k, it is equals to 42 into 3, which is equals to 126. Okay, so what is this? This is our required vector equation of the plane. So this is what the final answer for this question. Okay, so let's have a small dabba. Perfect. Now if they ask the Cartesian equation of the plane, so can you write? Just simply ij, k by x, y and z. So how we will write the Cartesian equation of this plane? So it becomes 2x plus y minus 2z minus 126 equals to 0. So this is the Cartesian equation of the plane. This is the vector equation of the plane. Okay, great. Now let's see the second question. So what is the statement is? Okay, so let me take from the book. So the second question is, find the perpendicular distance of the origin from the given plane. Okay, let's copy here and paste it. So see here, find the, again they are asking for the perpendicular distance. So perpendicular distance is nothing but p. Okay, so if you have not seen my previous video where I have discussed the normal form of the plane, I think it's a 7th scenario, so please go through that video so that it will be easy to understand this concept. So from this plane, okay, so first step we have to note it down that the plane equation is given in the Cartesian form. Okay, so let's write what is our first step. Step number 1 is given information. So given is what? They have given the equation of a plane in Cartesian form. So it's a 6x minus 2y plus 3z minus 7 equals to 0. What they have asked is the find the perpendicular distance. So they are asking us the value of p. Okay, so the third step is what? Write down the normal form of the plane. Normal form of the plane. So this question can be solved in two ways. Either you can take the same Cartesian equation or you convert the Cartesian equation into vector equation and proceed. Okay, we will see both approaches. So first let me take the second approach, that is normal form. So how we will convert the given 6x minus 2y plus 3z minus 7 equals to 0 in vector form? It's simply replace xyz by ijk and we have to give the r bar. So it becomes 6i minus 2j plus 3k, it is equals to 7. Okay, so this is what our vector equation of the given plane. Now we know that the standard normal equation of the plane is what? It's a r bar dot n cap, it is equals to p. Okay, this in this equation, what is this? This becomes the n bar. Okay, but we want the value n cap. So how we will proceed? So we know the n bar, so we can simply find out the n cap. So step number 4 is what? Find out the value of n cap, which is nothing but vector divided by its magnitude. So it's a 6i minus 2j plus 3k upon root of 6 square is 36 plus 2 square is 4 plus 3 square is 9, which is nothing but 6i minus 2j plus 3k whole divided by, it's 36 plus 4 40 and 49, so it becomes 7. This becomes my n cap. Now simply substitute this in the normal form, in this form, and you will get the value of n cap. Okay, so this becomes, we want the denominator as a 7, so r bar dot 6i minus 2j plus 3k, it is equals to 7. So if I want to convert this into the r bar dot n cap, so if I want to write this n bar as a n cap, so what should I do? Divide on both side by 7. Divide on both side by this quantity. Okay, 7 7. So this 7 by 7, it is equals to 1. So if in this equation, if this is r bar and if this is n cap, then what should be this? This value is nothing but the p, and which is the required answer. So the answer for this question is p is equals to 1, that is the distance of the plane from the origin is equals to 1. Okay, so this is the first approach. Now let's solve the same question using the second approaches. So second approach is, see here, the given equation of plane is what? It is a 6x minus 2y plus 3z minus 7 equals to 0. And I have already told you that if you know the coordinate of any point, suppose this is the point P we have, if you know the length of this point P from the origin, okay, let's change this and let's take this as a r point. If you know the distance of this point r, distance of this plane from origin, that is a P, and if you know its direction cosines, that is L, M and N, then the coordinate of this point are simply nothing but LP, MP, NP. Okay, so what you require to get the distance from the origin is, we should first write down this equation in the normal form, which is nothing but Lx plus My plus Nz, it is equals to P. Okay, this is the second form of the normal equation, which I have already derived in our previous classes. Okay, where L, M, N are the direction cosines of the point which is lying on the plane, and the P is the distance from the origin. Okay, so in the given equation, it is 6x minus 2y plus 3z, it is equals to 7. If I compare this equation with the standard equation, which is ax plus by plus cz plus d equals to 0, what are these values? A, B and C indicates these are the direction ratios of the normal vector. But what I want the direction cosines. So for that, what you will do, I will divide. Okay, so let me write the values of ABC. A is 6, B is minus 2 and C is nothing but 3. So find out the magnitude of this. So it is 6 plus 4 plus 9, which is nothing but root of 49, which becomes the 7. Okay, so if I divide on the both side, what I will get? It's a 6 by 7 x minus 2 by 7 y plus 3 by 7 z, it is equals to 7 by 7. Okay, and that is nothing but 7 gets cancelled, which is nothing but 1. Now if you compare this equation with this standard normal form of the plane, then you will understand that 6 by 7 is the first direction cosine, this is the second, sorry, this is a minus, we have to take inside second, and 3 by 7 is the third one. Okay, so perfect. So if it is the case, then this value simply becomes the p, which is the perpendicular distance of the plane from the origin. Okay, that's great. So you can solve this type of questions in any way, either vector approach or the Cartesian form approach. Good. Now let's see the third question. So let me take the question. So the question statement is like this: find the coordinates of the foot of perpendicular drawn from the origin to the given plane. Okay, let me paste here. So it is again very simple question. Just now we have seen the concept which is required in this question. Okay, so see here, find the coordinate of the foot of perpendicular they are asking, which is nothing but m. This we have considered during our proof. M from the origin to the plane, this is the given plane. Okay, so let me draw a figure for you. So this is m, sorry, this is the plane, and suppose this is the point m, and this is nothing but the foot of perpendicular drawn from the origin. Okay, so this is our x-axis and y-axis. This is the origin 0, 0, 0. Okay, so how you will get the coordinate of this point m? Just now I have told you, if you know the length of this segment OM, or if you know the perpendicular distance of this plane from the origin, which is denoted by p, and somehow if you are able to calculate its direction cosines, which are nothing but the LMN, then simply we can write down the coordinate of the point M like LP, MP, NP. This also I have proved in one of my previous video. Okay, so let's write down the given. Step number 1 is what is the given information, which is nothing but 2x plus 6y minus 3z, it is equals to 63. This is the equation of a plane in a Cartesian form. What we have to find out is the foot of perpendicular coordinates. Step number 3 is what? Write down or convert this 2x 6y minus 3z, it is equals to 63 standard equation into the normal form of the equation. Convert the given plane equation into normal form. Okay, so what is the given plane equation is? It is in the form of ax plus by plus cz plus d equals to 0. And what we require? I require the normal form, which is lx plus my plus nz, it is equals to p. Okay, so these are the ABC are the direction ratios, and LMN are the direction cosines. And what is the relation between the DC and DRs? That is nothing but L is equals to a upon root of a square plus b square plus c square, and so on for m and n. Okay, so let's take this equation of a plane and let's divide by their magnitude. So what is the equation of a plane is? It is 2x plus 6y, 2x plus 6y minus 3z equals to 63. Okay, so here a equals to 2, a equals to 2, b equals to 6, and c equals to minus 3. So root of a square plus b square plus c square will be equals to root of 49, which is equals to 7. Okay, so simply I am writing directly, I am substituting the a by root of a square, b square, c square. So what you will get? So it is a 2 by 7 x plus 6 by 7 y minus 3 by 7 z, which is equals to 63 by 7. So in this step what I am doing, I am dividing on both sides by 7 to get the normal form of the plane. Okay, so if this is the case, so this becomes the L, this becomes the N, and this becomes the N. Okay, so what will be this? So 63 by 7 is nothing but 9. Okay, So what is this then? So this is nothing but the distance of the plane from the origin. Okay, so here in this equation, L comma M comma N will be equal to 2 by 7 comma 6 by 7 comma minus 3 by 7, and the value of P is nothing but 9. So the foot of perpendicular coordinates will be equal to LP comma MP comma NP, which is equivalent to 2 into 9 by 7 comma 6 by 7 into 9 comma minus 3 by 7 into 9, which is nothing but 18 by 7 comma 54 by 7 comma minus 27 by 7. Okay, so that's great. So this is what the final answer is. So they are asking the coordinate of the foot of perpendicular. So this is the coordinate of foot of perpendicular drawn from the origin to the given plane. Okay, great. Now let's see the next question, question number 4. So let me take this statement. So it says that reduce the given equation of a plane to the normal form and hence find out the given 2, that is the length of perpendicular from the origin to the plane and its direction coordinates. This is the exactly same question which we have solved just now, that is a question number 3. Okay, so let me write down the step number 1 is what? Write down the given information, which is nothing but r bar dot 3i plus 4j plus 12k, it is equals to 78. So what is this? This is the standard equation of the plane. Now maybe you will have the confusion, sir, when to consider it's a standard equation or when to consider it's a normal form of the equation, because the normal form and the standard form looks like, okay, r bar dot n bar is equals to a bar dot n bar, this is what the standard equation, and r bar dot n cap, it is equals to p, this is what the normal form of the equation. Now if you see here, a bar dot n bar is also a scalar quantity and p is also scalar quantity, n bar is a vector and n cap is also vector. So you may get confused that the equation given is of which form. Okay, so the thumb rule says that if they have not mentioned anything, so thumb rule is what? Okay, this is the thumb. So if they have not mentioned anything about the equation, which form of the equation of the plane, we have to consider it's a standard form only. Always remember, we have to consider the standard form only if they have not mentioned anything about the plane. Okay, perfect. So they have not mentioned anything, they have directly said it's a given equation of the plane, so we have to consider it's a standard equation. Perfect. So let's take that standard equation and we have to reduce it to the normal form. So this equation we have to reduce to this form. So if I compare these two equations, so this becomes my n bar. So from that n bar, can you find out the n cap? Yes, why not? N cap is nothing but vector divided by its magnitude. So it's a 3i plus 4j plus 12k whole divided by its magnitude, which is given as root of 3 square is 9, 4 square is 16 plus 12 square is 144, which is nothing but 3i plus 4j plus 12k whole divided by its root of 169, which is nothing but 13. Okay, so sorry, it's not bar, it's a cap. Okay, so it's a cap. So to convert this vector into its unit vector, I have to divide by 13 here, but you cannot divide only on one side, so for that purpose I have to divide on both sides. Okay, so what will be our next step is step number 2 is what? Divide the step number 1 equation. So r bar dot, it's a 3i plus 4j plus 12k equals to 78. Divide this equation on both sides by 13. Okay, so I will be having 13 this side and 13 this side. Okay, so 78 divided by 13 is nothing but 6 za. So I will be having r bar dot, so it's 3 by 13 I plus 4 by 13 j plus 12 by 13k, this is equals to 6. Now I can simply say that this is the form of n cap, it is equals to 6. Okay, so this is the normal form of the equation. First part, convert or reduce the given equation into normal form. So this is what the normal form of the equation, and hence find out the value of the p, means what, the distance of the plane from the origin. Okay, so hence find out the length of perpendicular from the origin, which is nothing but p. Okay, so p is what, it is nothing but 6. Okay, here p is 6, and also they are asking for the direction cosines. So if this is in the direction that is a normal form of the vector, then the direction cosines will be what, these are the direction cosines, that is 3 by 13, 4 by 13 and 12 by 13. See, once you get the normal form, the question is very simple. Okay, so what is the value of L, M and N, which is nothing but 3 by 13, 4 by 13 and it's a 12 by 13. So this is our answer. Okay, first answer, this is the second, and this is the third. Great. Now let's see the last question of this video. So it's a fifth question. So let me have the statement. Find the vector equation of the plane passing through the point having the position vector and the normal vector. Okay, so it's very simple, basic question. So the given information is what, it's a, they have given the position vector which is a bar through which our plane is passing, I, j and k, and they have also given the n bar which is a perpendicular vector which is a 4i plus 5j plus 6k. Okay, so this vector equation you already know, it's a r bar dot n bar equals to a bar dot n bar. So let's have r bar dot n bar is 4i plus 5j plus 6k, it is equals to I plus j plus k dot 4i plus 5j plus 6k. So if you open the bracket, I will be having 4 plus 5 plus 6, so 4 plus 6 is 10 plus 5 is 15. So this is what the required equation is, 4i plus 5j plus 6k. Okay, so this is the vector equation. So how we will write its Cartesian equation? This will be 4x plus 5y plus 6z equals to 15. Okay, that's great. So answer to this question is, let me have and highlight this. So this is what the answer to this question. Great. Okay, so with this we will stop here, and next set of 5 questions we will see in the next video. Thank you.